So we can't we can possibly cover everything you need to know about SOC environments, right? The security operating centers are a pretty big deal, and there's a lot of things that is going on there. But I just want to share a few thoughts that help us with our workshop here. Now, there's a few SOC core capabilities, right? What you typically see is a SOC obviously is there for security monitoring, to see anything that's going on in the environment. Then also for incident handling, there's also threat intelligence and threat hunting capabilities, ideally. It also deals with vulnerability management, training and awareness, governance, risk, and compliance. But what we are mostly focusing on here is anything that has to do with active threat detection and response. And that's typically security monitoring, incident handling, and applying some threat intelligence, threat hunting. So that's what our focus is going to be. And what are we protecting? And this is where now I'm starting with some of the fundamentals. Some of the things, these are mostly covered also in the 101 course that is out there, but I really want you to get a refresher or some basics here that you need to know before we start diving into investigations. The first thing we need to know is that what we are protecting is an enterprise environment, and 99% of those environments these days out there are based on Microsoft Active Directory, which is basically what runs an environment. So Active Directory is basically what manages those domains. For example, you can have domains in environments such as here. There's sample.com. This is an internal domain, and then you can also have multiple domains joined together, which is basically an Active Directory tree. Or you can have multiple trees joined together, which basically assembles a forest. And the reason why this is important to know is that there's a lot of different types of permissions and privileges and accounts and everything floating around here. And it's really important to understand which users have what kind of privileges within which kind of domains, right? So sometimes there's a domain admin, or most always there's a domain admin, but sometimes there's also an enterprise admin, which can actually manage or access all of those domains. And so depending on the privileges and the criticality or the sensitivity of the account, those are prime targets for attackers. So this is why it's always important to understand the concept of domains, and that within a domain you have organizational units, and those units can include objects such as users, computers, things along those lines. And some of those users might have higher privileges that are really a juicy target for attackers to take them over, because then they can actually own the domain or an entire forest and then compromise those systems. And from personal kind of experience, I've already seen where when there's one Active Directory tree that is allowed to talk to another Active Directory tree by a trusted relationship, there's sometimes those relationships, there is some misconfiguration, and we have seen threat actors moving from one to another tree, and that's kind of how organizations sometimes are also getting compromised. For example, if you imagine this one, is a organization located in a different geography, such as Europe. This one here is over in the US, and then there's a trust relationship misconfiguration. If one organization gets compromised, the other one would probably, it would allow an attacker to pivot and compromise the other geography as well. And that's, sometimes worst case scenarios, and I've seen those before, but this is what we basically, protecting. Now, Active Directory is basically managing all of this, and that is implemented on domain controllers. And typically we have one or more domain controllers. And that's what they are basically doing, right? They have the Active Directory, which is a list of all the users and the systems and the objects that are basically part of the environment, so that if you log on to a workstation, the workstation doesn't know about your own user account. It goes out to the domain controller to authenticate you and authorize you, get you access to the workstation, depending on who you are and if you actually if you are who you say you are. And there's a lot more going on, right? Aside of authentication, domain controllers are used to push policies on workstations, such as configuration, security configuration, things along those lines. And that's also what attackers sometimes like to take over, disabling security configurations, or pushing their own malware, things along those lines. So understanding of group policies, and these kind of things. Active Directory in general is basic requirement for anyone who is working in an enterprise environment and detecting threats and protecting the enterprise organization. So that's just what I wanted to cover there. We can go, of course, much deeper in That's what we do in the course, but this is just the first thing of what we are protecting. Now, how are we going to do this? Here is a high-level list of things typically seen in a SOC environment. The way how we do this is there's the SOC visibility triad that's defined by Gartner, but this is what basically makes a lot of sense, right? We always have had the SIEM, the Security Incident Event Management System, which basically is just a centralized place to collect logs from a ton of systems from all over the place, endpoints, firewalls, all kinds of things. That always used to be the place where it got all the logs, and then it would do some correlation. You can do detections, alerts through the SIEM. It's still very useful, obviously, to run analysis across the logs that you have available to potentially find anything malicious, suspicious. But that's something that's been around for quite some time. And those are obviously pretty sophisticated these days, but it's just something that most of you are probably familiar with. Speaking of, Splunk, Elk, things along those lines. But then we also needed to get more visibility into the endpoints. So not just to rely on logs, but actually seeing anything that's going on on an endpoint, specifically, those things that are not being logged, like telemetry. And that would then be captured by tools such as the endpoint detection and response applications, so EDR. Now, EDR is really good because you get a lot of in-depth telemetry that is monitoring for anything suspicious that is going on on an endpoint. And then it's also a centralized place where you can then query across all your endpoints for any potentially suspicious, malicious activities. So that got us another level of visibility. And then there's still data that traverses the network. And then there's a lot of things that are just not on endpoints, but actually communicating with our endpoints or also with the external environment. So that's what we can capture in network detection and response. So now we're talking about the NDR tools. So that is the part where you got the in-depth kind of visibility into anything that goes on your network environment and the network and the wire. And by combining all of these tools and the visibility you get through it and the telemetry, this is what we call these days the XDR. So this is basically the combination, the best of all of these tools. And then obviously these days, there's a lot of providers and vendors that also add on a lot of AI and whatever special sauce capabilities. But that's basically what they need, the visibility, in order to actually make sense out of all the data, right? And this is actually now we have pretty good coverage across any spot in the environment that can help us to detect suspicious things. So this is the how, right? This is what we are typically looking at. But the one thing, this is one of my favorite slides, because the one thing that is always important is logging, telemetry, and visibility. We need to have visibility into anything because we can't detect what we can't see, right? It all starts with creating visibility, because without it, there's no chance for us to detect anything, analyze anything, respond to anything. So for that, we need to look into creating better telemetry. And telemetry is basically real-time metrics, so anything that's happening on endpoints, things along those lines. And then also there's a number of logs, obviously, floating around, which is logs are just the recorded events of activities. And that's what we need to get really good at in order to have a chance to detect also sophisticated attacks and attack techniques. So one thing that we can do, if we just looking at the endpoint, without buying any sophisticated tools or anything special, the first thing I would always do is, in order to create more visibility, better visibility, I would look into logging. And Windows Event Logging has a couple of features that are not even enabled by default. And the first thing I would do is, for example, look into PowerShell logging. PowerShell is being captured if PowerShell engine starts up. We have an event for that, but there's a few more tricks. So for example, in Group Policy Monitor Editor, you can actually turn on a couple of additional features. And one of the best ones that I like to use constantly is PowerShell script log logging. We won't go into details just yet because that's something we are going to be analyzing in the next session, but script log logging allows us to capture the payload of PowerShell executions. For example, if you have an obfuscated payload, that might actually be captured within a script log event. And that's pretty awesome, right? Because that actually will show us what an attacker was executing in terms of PowerShell and within the scope of a PowerShell process. And that can go a long way. So really cool also in terms of detection. Script block logging also has its own detection capabilities. It actually adds warnings to like some of the suspicious executions that might contain suspicious terms, just terminologies. It's pretty straightforward, but a really helpful tool or feature. And then we can enhance our visibility, right? A lot of people have probably heard about Sysmon. Still by far the most favorite tool of mine, because as long as you have Sysmon, you can basically see anything that executed, any network connection, any registry operation, any file creation, file streams. There's just so much that Sysmon can log, but it's not a log that comes with Windows by default. You have to install it, you have to install a driver, and you would have to deal with a ton of data, right? Because it creates a ton of events. And there's always a discussion on how, trade-off between how much data you want to generate and what's worth it, because also storing data is expensive. So with Sysmon, you create a lot of data. The question is just, how can you store it? How much data can you handle? And that's the answer is basically, it depends, right, on every organization. But even if you don't have any storage capacity on Sysmon, just leave it on the local system and set it to to 100 meg or something. Because if I have a compromised system and it has Sysmon logs on it, even though I have to grab those manually, it would still be the best case scenario, right? Because you can see just a lot of things that happen on the system. So just a few quick and easy wins in order to get some additional telemetry going here. And that's just endpoint. Now, there's a lot of more stuff that's going on in an enterprise environment, right? And a lot of that has to do with network communications. And so that's why there is a lot of additional data points that we can look into. And each one of those, and this is not a conclusive list, but this is like all of these things already have been helpful in one of my previous cases before. So of course, endpoints also have a firewall, and mostly those Windows firewall logs and things along those lines. So there's some special, with Sysmon also, you can log network traffic and firewall logs. But not just on the endpoints. We have a lot of things that make networking possible. So on those switches, on those routers, you can get additional logs, NetFlow logs. You can get packet captures. We can look into IDS and IPS, intrusion detection prevention systems. So that's already a lot that just traverses the wire, which is always interesting to look at if you have a chance to get that. But there's also proxies and additional firewalls. And while those might be a little tricky sometimes to look at because there's just a ton of data, especially in firewall logs, and you have to chain them together to understand what communicated where, how, it is still a very important place, because with proxy logs, I was already able to solve a lot of things, a lot of cases before, just by seeing who communicated with what kind of external sources. Same for DNS, right? Just seeing who was doing DNS requests to which kind of domains. DHCP logs, seeing who is actually part of your network, and then applications logs. Anything nowadays, application web services are often exploited. So if you have a vulnerable application, you hope that there's actually logs that you can use in order to find evidence of an intrusion or potential exploit of the vulnerability. And a lot of more things, VPN logs. If you have a compromised remote worker, they might actually have, then the threat actor might actually have access through VPN to your environment. So those logs can be very helpful there as well. And probably a few more, but this is already a whole, very comprehensive list of, and a lot of work to get all the data somewhere sorted and organized. But I'm just saying, there's a lot that goes with it. It's not just endpoint endpoint analysis. There's a lot that you can do in the network as well. Now, let's break it up real quick. So I'm assuming that a lot of people have some basic understanding of networking here, but what are the interesting information that we can get out of it? And so one of these things that we can look at are PCAPs. And we are going to look at PCAPs later, so that's why we have it here too. But basically in PCAPs, we have, this is a packet capture. It's basically a frame that is going to contain raw network traffic data. And so we have, the basic layers of the frame and the Ethernet layers, and then we have the IP layer. And on the IP layer, we can already tell where this packet was connecting to. So basically what the destination IP address is. And that's the first indicator. The second one, a level above, a layer above, we have TCP. The TCP protocol basically defines, which port we are connecting to. So here we can see we connected to this IP address on port 80. So that's another interesting IOC, an indicator of compromise, if that is part of an investigation. And then, depending on what the protocol is that we are connecting with. For example, web services are using HTTP. So HTTP would then include, the layer for HTTP would include the type of request, which is GET requests here, for example. We'll have the URL, what we connected to. We have the domain that we connected to. We also have a user agent that we connected to. So for a browser, that's typically, Firefox, Chrome, or whatever. For some more scripted, automated kind of tools, you would have the tool name, or you would have Python here, for example, which is usually not a great sign. But those are just the different kind of indicators that we can take away from just a simple packet capture. Now, it can go further. The packet capture is great, and we can then filter for malicious IP addresses or ports or URLs that might have been connected to. But on top of TCP, we often have SSL, TLS encrypted traffic, and so we can not always, as easily at least, look into what's inside of the payload of what's in an encrypted packet, but we can look into some of the metadata. And so if there's an encryption going on, if TLS is being used, there's typically a handshake happening. So the source and the destination would connect with a handshake saying, there's a client hello request, and then there's some back and forth where they negotiate the type of encryption that is being used going forward. And for these 2 or 3 package exchanges, there's a couple of things that we can actually use to uniquely identify that kind of particular host and the communication. And for TLS, when you have a handshake, there is typically a number of things that are included in the metadata, such as the TLS version that is supported by the client, the cipher suites that are supported, extension length, a lot of different things, as you can see here indicated by the arrows. And if you take that is pretty unique based on the client or the server, because that has a lot of different individual kind of information in there. And individual information basically can mean that if we chain it all together, you could create something such as a string of the IDs. So if you have all of these things numbered by an ID, you can create IDs for each. And once you hash those IDs, you can come up with a pretty unique hash. And that's called a JA3 or 4 fingerprint. And that's what you can find in packet capture sometimes. So this is a Wireshark packet capture of a TLS request. And so, for example, if you create a unique fingerprint of this particular client, the TLS protocol basically that is being used, you can basically uniquely identify this particular system on your in your environment, or if it's a server, you can uniquely identify this server with, even though if the IP address is going to change, or the port or the URL. So if you don't know anything, if you have a compromised command and control server, something that your host is communicating with, even though they change the IP address or the domain name or whatever, you can still create, sometimes use a hash such as the JA3 hash to uniquely identify communication with the server. And that's just a thing that I wanted to add on, since we're already talking about network traffic and indicators here. It's really interesting. People at Salesforce came up with this. You can read it up on this here on the Salesforce site, or just Google it, JA3 and JA4. Pretty cool additional kind of a way of how to identify systems. All right, so there was a lot of, speaking of telemetry, how can we identify things? How can we identify the telemetry that we need for that?